Namaskar, my dear friends. In our previous video, you have learned about the different conic curves and methods of drawing different conic curves like ellipse, parabola, and hyperbola. Now today, we are going to learn about the cycloidal curve. Okay, so before learn about the cycloidal curve, let us understand what is the volute. So cycloidal group of curves, when one curve rolls over another curve without slipping or sliding, the path of any point of the rolling curve is called a volute. Okay. So when the rolling curve is a circle and the curve on which it rolls is a straight line or a circle, we get a cycloidal group of curve. Okay. So if this curve, the rolling curve, is a circle and on which it rolls is whether a straight line or a circle, then the path of any point on that rolling curve is known as a cycloidal group of curve. Now, classification of cycloidal group of curves. So there are three types of cycloidal curves: cycloid, epicycloid, and hypocycloid. So cycloid is classified by two different ways. One is the inferior trochoid and superior trochoid. Similarly, epicycloid is classified by inferior epitrochoid and superior epitrochoid, and hypocycloid also classified by inferior hypotrochoid and superior hypotrochoid. So these are the different types of the cycloidal curves. Now, first one is the cycloid. What is the cycloid? The cycloid is a locus of a point on the circumference of a rolling circle that is known as the generator, which rolls without slipping or sliding along a fixed straight line or a directing line or a director. Okay, so if any circle which is rolling without slipping or sliding on a straight line, then any point on the circumference of that circle, the path of that point is called a cycloid. Now let us see here. See the center and one circle is there. Okay. Now this circle is known as the rolling circle or generator because it is generating a curve. That's why it is known as a generator. Now here you can see directing line or director because it directs the rolling circle. That's why it is known as the directing line or director. Now this circle is rolling on this directing line by one complete revolution. Okay, and the P is a point, this contact between this circle and directing line, and the point P is on the circumference of this rolling circle. So now it is rolling in this direction, clockwise direction. So after 1/2 revolution, this circle will reach at here. Okay, so the position of the circle after the 1/2 revolution. So at that time, a point on the circumference of this circle, it will reach at the top of this circle. Okay, now for the next 1/2 circle, okay, the point P will be reached at here. Now the path of this point P, okay, and the center will be here. So this path of point C is known as a cycloid. So this curve is known as a cycloidal curve. Then next one is a epicycloid. So epicycloid is a locus of point P on the circumference of a rolling circle or generator which rolls without slipping or sliding outside another circle called the directing circle. Okay. So if any circle is rolls over another circle, then the path of point on the circumference of the rolling circle is known as a epicycloid. So you have to remember that the circle is rolling outside the another circle. Okay, outside the another circle, then it is known as a epicycloid. So let us see here the circle. This circle is a rolling circle. Okay, and this circle is a directing circle. Now this circle is rolls over this another circle. Okay, so after the one complete revolution, it will travel an angle phi. Okay, so after the one complete revolution of the circle, it will reach on the other side, and the radius of the directing circle is RD, and the radius of this generating circle is R. Now here this arc P0P is circumference of a generating circle. So therefore, you can find this angle phi. This angle phi is equal to, so RD into phi is equal to 2 pi R. So therefore, this angle phi is equal to 360 degree into small r upon capital R. Small r is the radius of a rolling circle, and capital R D is the radius of directing circle. So by this way, you can find this angle phi. Okay, angle phi. So after the one complete revolution, the angular displacement of this circle is a phi. So at P0 is the initial point here. It is rolling. So after the 1/2 revolution, the circle will reach here, and the position of point P0 will be here. And after the one complete revolution, the point P0 will be here. So the path of this point P is known as a epicycloid. So this curve is known as epicycloid. Now next one is the hypocycloid. Hypocycloid is the locus of point P on the circumference of a rolling circle which rolls without slipping or sliding inside the another circle called the directing circle. So difference between the hypo and EP is that in hypocycloid, the rolling circle is rolled inside the directing circle. When circle rolls inside the directing circle, then the path of the point on the circumference of rolling circle is known as a hypocycloid. Now let us see here. You can see this green circle is a directing circle. You can see, and this circle is a rolling circle whose radius is R, and the radius of the directing circle is capital R. Okay, it is rolling inside this circle. So you can see the direction of the rolling. So initially the point P at here, after the one complete revolution, it will travel the angular distance displacement of phi. So the final position of point P will be here, and this curve is known as a hypocycloid. Now what is trochoid? Locus of point inside or outside the circumference of a rolling circle which rolls without slipping or sliding along a fixed straight line or a fixed circle. Okay, so in case of the cycloid, epicycloid and hypocycloid, we know that the point is on the circumference, but here you can say this is the circle. If our point will be here, okay, the point P will be here. So we can say this point P is outside the circumference of this circle. Okay, so the path of this point P is known as the trochoid, and if it is the outside of the circle, then it is known as the superior trochoid, and if this point is inside the circle, then it is known as a inferior trochoid. We discuss if the point is inside the circumference of the circle, it is called the inferior trochoid, and if the point is outside the circumference of the circle, it is called the superior trochoid. Now, I hope you can understand very well about the different terminology used in the cycloidal curve. Now, let us see how to draw a cycloid by one problem. Draw cycloid for one revolution of a rolling circle having diameter as 60 mm. Okay, so we have to draw the cycloid. That means cycloid means a circle which is rolling on a straight line. Okay, and the diameter of the circle is 60 mm. So first of all, we have to draw a circle of diameter 60 mm. Okay, this is known as the rolling circle. Okay, and diameter is 60 mm, right? And this direction, which shows the direction of rotation of this circle. Now divide this circle into the 12 equal division: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay. Now we have to draw a directing line. Okay. This is known as the directing line. And what will be the length of this directing line? So the length of this directing line is equal to pi d. So here in our case, you have to multiply this 60 with pi. So you will get the total length. Okay, or we can say 2 pi r. So length of the directing line is 2 pi r or pi d. Now divide this directing line into the 12 division. Okay, number of divisions equal to number of divisions of circle. So divide this directing line into the 12 division: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay. So now here this point is the center of the circle, and initially the center is C0. Okay. So after the one complete revolution, this circle will reach at here at this point. Okay. So this is the center line. Now we have to divide the center line into the 12 number of parts, and the parts are C0 in the center. Okay. Then C1, C2, C3, C4 up to the C12. Okay. Now when this circle rolls 1/12 of the revolution, at that time the center C0 will reach at C1, and this point 1 of this circle, it will match with this point 1 on a directing line. Similarly, if it rolls up 2/12, then the center C0, it will reach at C2, and so on. The center C0, it will reach at a C12 points. Now the next step is draw line which are parallel to the directing line passing from the different points of the circle. So from 1 and 11, from 2 and 10, okay, and 3 and 9 already drawn, 4 and 8, 5 and 6, 5 and 7, and 6. Okay. Now the main part of this, you have to remember that the radius remains constant, equal to radius of the rolling circle. Okay, so here the radius is small r, or we can say the radius is equal to 30 mm. Okay, and first of all, this P0 is our initial point. The point P is at here. Okay, now C1 as the center, radius equal to radius of rolling circle, and draw one arc. So you can see this arc will intersect this line passing from point 1 at point P1. Similarly, the center is C2, and draw arc same radius. So it will intersect this line passing from 2 and 10 as P2, and now C3 center and draw arc. So it will intersect this line which is passing from point 3 at point P3. Now C4 center, draw arc. it will intersect the line which passing from point 4 at point P4, and here same you will get the point P5, point P6, P7, P8, P9, P10, P11 and P12. So radius remains constant and we have to change the center from C1 to C12. Now join all these points P0 to P12 by a smooth curve. So this curve is known as a cycloid. Okay. Now if you want to draw the tangent and normal at this point S on this curve, then first of all this S as a center and radius equal to radius of rolling circle and draw arc which will intersect this center line at point S1. Okay. Now from point S1, draw a line which is perpendicular to the center line and it will intersect the directing line at point N. So now join this N with S. So this N is a normal and draw another line which is perpendicular to normal from passing from point S is known as a tangent. So this is known as a cycloid. Now let us understand epicycloid by one problem. A circle of 25 mm radius rolls on the circumference of another circle of 150 mm diameter and outside it. Draw the locus of point P on the circumference of the rolling circle for one complete revolution of it. Name the curve and draw tangent and normal to the curve at a point 115 mm from the center of the bigger circle. Now you know that here the circle is rolling over the another circle and outside it. So that's why we can say the curve is a epicycloid. Okay. Now let us see. So first step is find out the included angle phi by using the equation. You know that the 360 degree into small r is the radius of rolling circle, capital R is the radius of directing circle. So 360 into 25 upon 75 is equal to 120 degree. Second step, draw a vertical line and draw two lines at 60 degree on either sides. Okay, so total angle is 120 degree, that's why. Third step, at a distance of 75 mm from O, draw part of the circle taking radius equal to 75 mm. And fourth, from the circle, mark point C outside the circle at a distance of 25 mm and draw a circle taking the center as point C. So these are the different steps to draw the epicycloid. Okay, now as per these different four steps, first of all, we have already find the angle is equal to 120 degree. So point O, now from point O, draw a vertical line and on the both side of this line, draw to another line at an angle of 60 degree, 5 by 2, 5 by 2. Okay. Now this O as the center and radius equal to 75 mm and draw directing circle. Okay, so this circle is a directing circle, radius is 75 mm. Now from this point, okay, mark the center which is equal to 25 mm on this line and draw a rolling circle whose radius is 25 mm, right? This is a rolling circle. Now divide this rolling circle, center is C0, divide this rolling circle into the different 8 division here, 0, 1, 2, 3, 4, 5, 6, 7 and 8. You can divide 12 division also. Okay. So now divide this angle phi into the 8 division. Okay. So after the one complete revolution, this circle will reach at here. So C1, C2, C3, C4, C5, C6, C7 and C8. So you have to divide this angle into the 8 different division. Now this O as a center and radius equal to O1 and draw a circle which will passing from the point 1 and 7. Okay. So similarly the center will be O and draw the different circle which are passing from all these point 1 to 8. So circle passing from 1 and 7, from 2 and 6, from 3 and 5 and from 4. Now you have to take the radius equal to rolling circle, that means the 25 mm, and take the different centers C1, C2, C3, C4, C5 up to C8 and draw arc. So first one, C1 as a center, radius equal to 25 mm and draw arc which will intersect the circle passing from point 1. That point will be P1. So initial point P0 will be here. So here you can get point P1. Similarly, C2 as a center, you will get the point P2 will be here. Similarly, point P3, P4, P5, P6, P7 and P8. Now join all these points by a smooth curve. So this curve is known as a epicycloid. Right? This curve is known as a epicycloid. Okay. Now we have to draw a tangent and normal at a point which is 115 mm. So point S will be here, okay, at a 115 mm. Now from S as a center, radius equal to 25 mm and draw circle, and it will intersect this center circle at a point U. Now join U with O, okay, and it will intersect this directing circle at a point N. Okay. Now join this N with S. It is known as a normal, and this draw a line which is perpendicular to this normal is known as a tangent. Now the next, a circle of 80 mm diameter rolls on the circumference of another circle of 120 mm radius, and inside it draw the locus of the point P on the circumference of the rolling circle for one complete revolution of it. Name the curve and draw tangent and normal to the curve at a point 100 mm from the center of bigger circle. Now here the circle which is rolling inside the another circle. So that's why this curve is known as a hypocycloid. Okay. So first of all, we have to find out this included angle. Okay. So as per the equation, phi is equal to 360 into small r upon capital R. Right. So included angle is equal to 120 degree. So similarly, in previous example, draw a line vertical and 5 by 2, that is the 60 degree on each side. Okay. And radius is equal to R, means the directing circle radius. Okay. And draw a circle. Now inside, take a center and draw another circle of radius equal to small r. That means the 40 mm. Okay. This circle is known as a rolling circle. Now divide this circle into the 12 equal division. The direction of rolling of this rolling circle is given here: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Okay, so these are the different points. Now here draw the center circle and divide this circle into the 12 division and name it C0 to C12. Okay, so C1, C2, C3 up to C12. Now similarly, this O as a center and draw a different circle passing from the point 1 to 12. So 1 and 11, 2 and 10, 3 and 9, 8 and 4, 7 and 5, and finally 6. Now procedure remains same as in epicycloid. C1 as a center, radius equal to radius of the rolling circle, and draw R. Initially the point P0 will be here. Now C1 as a center, radius R, so you will get the point P1 at here. Similarly C2 center, you will get the point P2. Now C3 center, you will get the point P3. Similarly, find all the point P4, P5, P6, P7, P8, P9, P10, P11 and P12. Now join all these points by a smooth curve. So this curve is known as a hypocycloid. Now let's draw the tangent and normal at a point of 100 mm from O. So point S is here. Okay. Now from S as a center and radius equal to the rolling circle radius, and draw a arc which will intersect this center circle at this point. Now join this point with O and extend it up to this circle, and this point is N. Now join this N with the S, so it is a normal and another line which is perpendicular to this normal is known as a tangent. Okay. Now one more example. So by means of a drawing that when the diameter of rolling circle is half the diameter of directing circle, the hypocycloid is a straight line. Okay. So diameter of rolling circle is half the diameter of the directing circle, then the hypocycloid you will get will be a straight line. Now let us understand. Here this O is the center, another point C will be here. Okay, so this is the rolling circle. Okay, and the diameter of this directing circle is double this rolling circle. So now from O as a center and radius equal to diameter of rolling circle. Divide this circle into the 12 division and draw a directing circle. Okay. Similarly, draw a different circle passing from the different points 1, 2, 3 up to 12. Okay, and here you will get the center from C1 to C12. Okay, now the centers are C1, C2, C3, C4 and up to C12, and radius equal to the rolling circle, and draw different arc. So you will get the different points P1, P2, P3, P4, P5, P6, P7, P8, P9, P10, P11 and P12. Now join all these points So you will get the straight line. So here hypocycloid is a straight line. So if the diameter of directing circle is double the diameter of rolling circle, then its hypocycloid is a straight line. So I hope you can understand very well about the different cycloidal curves and how to draw the cycloidal curve. Thank you very much. Now in our next lecture, you will learn about the involute curves.